Hey there, and welcome to Decoding the Digital Lab with CSols, the podcast that understands the changing technology and landscape of lab informatics. I'm your host, Megan Pettyjohn, and in this series, we're speaking to the latest buzz that people are trying to understand. In this episode, we'll discuss the buzz around AI and what you need to think about before you start using it in the lab. Joining me is Glenn Everett, a seasoned lab informatics professional with a passion for integrating cutting edge technologies into laboratory environments. Hey, Glenn, thanks for joining me today.
Hey Megan, great to be here. AI has made some huge leaps in the past few years, and I've been watching to see where it will be heading and where it might lead AI in the lab here for everyone.
Yeah, it feels like everyone's talking about the potential of AI in the lab, but sometimes the practicalities of actually implementing it get a little lost. So, today I'd really want to dig into what labs need in terms of infrastructure, training, buy in, and successful metrics to truly support AI, because it's not just about installing some software.
Not at all. You can't just plug in an AI brain and expect it to work miracles. There's the foundational infrastructure that needs to be in place. Think about it. Your AI is going to thrive on the data that you give it. So you need your robust data storage. That's just critical. Then we're also talking about your massive data sets, especially if you're dealing with things like genomics or high throughput screening.
Yep, that makes sense. You need a place to put all of that information, and then I imagine you need the horsepower to actually process it.
Processing power is the next key component. Many of your AI algorithms, especially those for your complex tasks like image analysis, predictive modeling, they're going to require a significant amount of computational resources. Often means investing in high performance computing clusters. You can leverage your cloud based solutions with powerful GPUs. Your standard lab PCs that they hand out to everyone, they're not going to cut it.
So, we're talking about a potentially significant investment in hardware. And beyond the physical infrastructure, there's also the software side of things.
Correct. Specialized software is another consideration. This is going to include your AI and ML libraries and frameworks themselves, but also the tools that are needed to manage those. You're going to have to clean them, prepare the data for your AI analysis. You might end up needing platforms for your data annotation, model training, deployment. It's a whole ecosystem that has to work together.
Okay, so it sounds like a layered approach. And I imagine the specific infrastructure needed really depends on what a lab wants to do with the AI in the first place.
Precisely. Before even thinking about hardware and software, the lab needs to clearly identify the AI goals. Are they looking to automate your routine tasks? Are you looking to improve your data analysis, predictive model development? These use cases that you define are going to be what dictates the type and scale of the infrastructure required. You wouldn't need the same level of processing power for your simple data cleaning as you would for training a complex deep learning model.
That's a great point, starting with the why before the how. And I know there are different levels of AI adoption in the labs. Can you touch on that a bit?
At the basic level, it's the simple data automation, visualization, things like that. You're going to move up to things where it's going to be data analysis and anomaly detection. Then, even further up the chain, you have your deep learning modeling and generative AI for things like de novo drug design. Each level is going to require an increasingly sophisticated infrastructure.
It makes sense that you'd crawl before you run with something as complex as AI. Trying to apply AI everywhere in your business all at once would not be productive, rather overwhelming. Now, one area I think that has a lot of potential is integration with lab instruments. Can AI play a big role there?
There's a lot of potential there. AI can help standardize your instrument operation and data output across your instrument groups and your different labs. For example, AI powered image analysis can ensure your consistent interpretation of results from various microscopes. In chromatography, AI has been able to help optimize instrument parameters and standardize your peak integrations. This not only improves your data quality, but it also makes it easier to compare your results across your different experiments and your different locations. However, there are publications, Nature specifically has highlighted concerns about AI's effects on the reproducibility through the image classification. So results should always be verified by a human.
That consistency and comparability that AI brings to the huge data sets is crucial for robust research. And it's interesting to think about how AI's use might differ between the business and the actual lab operations.
Yeah, on the business side, AI is used mostly for predicting your equipment maintenance needs, optimizing your resource allocation, and potentially forecasting research trends. In the lab itself, it's more about direct scientific applications like data analysis and automation of your experiments, drug discovery. Understanding those different use cases will help tailor your complete suite of AI tools and your integration investments appropriately.
Another consideration when implementing AI into the lab is training the lab personnel. Training them to effectively use these AI tools is a must, but could also be a significant undertaking.
It is, Megan. We're essentially talking about developing new skill sets within the lab. It's not just about learning new software interfaces, it's about understanding the underlying concepts of data science and AI. This might involve training in data wrangling, statistical analysis, and even basic machine learning principles. There needs to be a strong collaboration between the AI experts and the lab researchers to bridge that knowledge gap.
That sounds like it could be another layer of complexity on top of the already sometimes challenging process of training staff on a new limbs.
Implementing or maintaining a LIMS can already be a hurdle. Adding AI tools on top of all that requires thoughtful and well planned training strategy. One of the first and most important steps is clearly communicate to the lab personnel how the AI will be used in their specific workflows. Addressing potential anxieties about job security and highlighting the benefits, how your AI can automate tedious tasks so that they're freed up for more rewarding work, is crucial to reducing that resistance. Industry reports often cite lack of user adoption as a major barrier to successful implementation in the lab.
Funny, I actually touch on that subject in another podcast episode about the cultural shift needed when implementing new technology. That proactive communication and highlighting the what's in it for me for the lab staff is essential for buy in at all levels. Now, speaking of buy in, what about getting the green light from decision makers higher up in the organization? Are labs encountering any pushback with AI adoption?
Do they ever? Labs often face pushback from the higher ups for various reasons, whether it's the perceived cost, the lack of understanding of the benefits, or even just general resistance to change in the unknown. There can be a lot of red tape to navigate.
So, what's the best approach to these conversations with decision makers? What do they typically want to hear?
Well, this is where those use cases I mentioned earlier come in handy. Decision makers want to hear about the specific use cases and ultimately the ROI. You need to clearly articulate how your AI will address the specific business challenges and contribute to the bottom line. Is it going to reduce your turnaround times, lower your operational costs, improve your research output? You need to speak their language and frame the benefits in terms that align with their strategic goals.
Yeah, all those questions make sense. Even though AI is a cool technology, it should really be implemented based on its tangible business impact. So, when getting buy in, should you also address preconceived notions about AI in case those are a factor in the decision making process?
That would be my recommendation. New technology will always bring preconceived notions, especially with AI. Either overly optimistic views of AI, imagine your own personal R2D2 C3PO following you around, helping you with your daily tasks, or you have the overly pessimistic fears about its capabilities and risks. Imagine if it was Terminator following you around instead. It's important to address these head on with realistic expectations and data backed projections.
Yeah, I definitely would not want the Terminator following me around. When considering the ROI of AI, what specifically should be addressed?
A few things. First, the labs need to focus on the technical accuracy of the AI, things like precision and recall. Secondly, decision makers want to see the broader success metrics that align with their business goals. How will this AI actually impact the turnaround times in a measurable way? What's the projected cost reduction? How will it improve that research output or you're able to enhance the compliance? Without these broader metrics, it's very difficult to demonstrate a clear ROI and justify further investment.
Yeah, that makes perfect sense. You need to show how the AI technology translates into tangible business value. One last crucial piece I want to address when you consider implementing AI into the lab, and that's the data itself. Many don't realize that their data may not be ready to implement AI technology. What should they do?
Bad data in, bad results out. And I was just saying that to one of my clients this morning. You can't just jump in and use AI. Your data has to be properly prepped for it. That can mean a significant effort for data cleaning, standardization, and often annotation. The quality of your AI output is directly tied to the quality of your input data. It's critical, but often overlooked step in the AI implementation process.
True. And CSols is actually a partner with a scientific data platform that helps labs do that. Name drop Zontal, if you want to check them out. So, Glenn, at the end of each episode, I'd like to ask my guests that to leave the listeners with a one piece of advice or a tip to help them achieve excellence. Do you have something for our guests when considering implementing AI into the lab?
My piece of advice for implementing AI tools and processes would be focus on using AI to make the workload of the users more manageable. AI is not at the point of doing everything for the lab, but there have been enough significant increases that harnessing it now or letting it marinate a bit more works, while you focus on the success criteria and keeping expectations in line with that criteria.
Well, this has been such a comprehensive overview of the infrastructure, training, the buy in, and the data considerations for AI in the labs. And I really appreciate your guidance on this subject matter.
My pleasure, Megan. It's complex but incredibly promising area.
Well, that's all we have for today. Thanks for joining us for this episode of Decoding the Digital Lab with CSOLS. Join us next time. Don't forget to hit the follow button if you're enjoying this content. We also have a newsletter that it goes out once a week. It's about current events and you can sign up for it really easy. Either click the link below or there's going to be a link in the bio of the podcast.